This lesson is to help you with composition of functions. You already perform compositions. When you have a problem like this, John's parents give him $5 each week for allowance. He can earn extra allowance by helping clean the stables at the barn. He earns $2 for each stable he cleans. So how much will John earn this week if he cleans 6 stables? Well, you probably already calculated that you can say, well, if he cleans 6 stables at $2 each, that's 12. And so I'm going to add that to what he already gets, so he'll get $17. Well, here's what you're doing. You're saying that you have this function of what is John's allowance? We're going to call that J. Okay, so John's allowance is $5 plus his extra earnings. So I'm just going to call that E for his extra earnings. Well, you figured out what E was by saying, okay, well, E equals $2 times however many stables he cleans. Let's just call that X. So you actually did this computation and then put it in here to get your results. That's a composition of functions. Here's what it looks like mathematically. What I'm saying here is that you have two functions. You have G, which is this one, and you have F here, and we want to get one answer and then plug it in the other. So F of 3, this is my X value, so I'm going to replace this X with this 3. So it will be 3 squared minus 3. So I'm going to compute that first. Notice I'm computing what's on the inside and then taking it to the outside. So I get 9 minus 3, which is 6. So now I'm looking for G of 6. So I look up here and see, okay, well, what is my G function? My G function is the square root of 4x plus 1. So I'm going to put that 6 in for that x. So the square root of 4 times 6 plus 1. That's the square root of 24 plus 1, so it's the square root of 25, which is 5. Okay, now I'm throwing in another function, h of x. Notice that's written here. So h of x is 2 times x to the 1/3, or the cube root. And also notice that this time I don't have a value. I just have the letter x. So I'm not really changing my h of x. So I'm still just hunting for f of h of x. So I'm just going to copy my 2x to the cube root, or excuse me, 2 times the cube root of x, and I'm going to put that into my f function. So instead of, so here's what f of x looks like. This is f of x. And I'm going to replace this x with the whole function 2 cube root x. So I'm just going to rewrite it. 2 times 2 cube root of x, squared minus 3. Now notice that h equals 2 cube root x, and I've written that entire expression here in place of that 1x that was in my f function. So now when I do this, remember I'm going to do that part first because I do powers before I do multiplication. So I have 2 times 4x to the 2/3 minus 3. So that becomes 8x to the 2/3 minus 3. Now here's a new notation. The left side of the equal mark is exactly the same as the right side, only written a little differently. It's f composition g of x. So it really is exactly the same thing. So if this notation is confusing to you, just rewrite it like this. Just keep your letters in the same order and you'll be fine. So let's try this one. What happens when I do this? Now I'm always starting on the inside first, so I need to find the g of x first. Well, g of x is just x plus 4. So I'm going to take that value and put it in for each one of my x in the f of x function. Okay, so notice that in my original function it was x squared minus 2x minus 7. And so now I have just rewritten each one of these x's with my g of x, because my directions are to take the g of x and this whole function and put it into my f. So when I do that, remember how to multiply x plus 4 times, this means x plus 4 times x plus 4. And then I'm going to use the distributive property, but I have to multiply a binomial. Most of you know that as a FOIL, so that would be x squared plus 8x plus 16 minus 2x minus 8 minus 7. Now I'm going to combine like terms. And here I have plus 16 minus 8 minus 7 is just going to be plus 1. Okay, and then we're going to leave it like that. Okay, let's try these. F of x plus g of x means that we're just going to add the two functions, and remember to use like terms, combine like terms. So f of x is x squared minus 2, and g of x is x cubed plus 4x. There are no like terms there, so I'm just going to write the terms in decreasing order. Okay, now this dot means multiplication, whereas remember this one is where you are taking the composition. So pause the video and try these for yourself. How did you do? Notice that, parentheses missing here, notice that these two are the same. It's just a different way of writing the same set of instructions. There are other ways to find compositions as well. You can do it graphically. For example, here I have two functions graphed. The red one is named h of x and the purple one is named w of x. H of 2, remember whatever's in the parentheses is your x value. So h of 2 I'm going to come over here to where 2 is on the x-axis, and I'm going to my h function. When I do that, I see that the value right here, where x is 2, the function equals 1, 2, 3, 4, 5. So the function equals 5. If I do the same thing with w, so now I want w of 1, so I'm going to 1 here on my x-axis. I'm going up, and I get to this point on my w function. This is 8, so I know at 1, the w function equals 8. Okay, w of negative 2. Again, remember this is your x value, so I'm going over to the negative 2, and I don't have to go anywhere else because it's crossing the axis there, so I know that that point is negative 2, 0, so my function equals 0 there. H of negative 4, go over to the negative 4 and up, and that point is negative 4, 8. So I know that that point is 8. I know that the value of my function, of the function h at negative 4 is 8. Now you can do this with the chain reactions also, where you start on the inside and work your way out. So I'll do the first one, and then you pause the video and try the others. H of w of negative 2, so again I'm going to the negative 2, and I get an answer of 0. So that tells me this is 0, so now I'm hunting for h of 0. So I go to the 0, and I go up to my h function, and that is 1, 2, 3, 4, 5, 6. That point is 0, 6. So I know that entire thing equals 6. Okay, you pause the video and then come back and check your work. Okay, how did you do? Another way is to use charts. So remember again that the value inside the parentheses is your x value. So I go to negative 1 in my chart, and I'm asked to find, well, what's the value of the function t at negative 1? And I can see here that the value is 1. The value of the j function at negative 1 is 2. Now, when I'm using the composition of functions where I'm finding one and then the other, I do exactly what I've been doing all along. Start on the inside, so j of 2 is negative 1. So now I'm hunting for t of negative 1. T of negative 1 is 1, so there's my final solution. T of 0 is negative 2. So now I need to find j of negative 2, which is 3. So compositions are really just chain reactions. And so what happens on the inside carries to the others. So when I have a function such as f of x equals x plus 2, g of x equals 4x, and I want to know, I could do it multiple times like this. Okay? What this means is I'm starting with my f of 0, g of 0, excuse me. So it's going to be 4 times 0, which is 0. So I'm going to bring down all my other work. Then, excuse me, g of 0 is 0 again. So now I need f of 0, which is x plus 2. My x is 0, so that just gives me 2. So you can see that one value just carries down to the next, creating that chain reaction. I hope this has helped you understand the composition of functions. So pause the video, write the problem down and work it, and then come back and see the answers. How did you do?